In the real world, data usually doesn't follow a nice linear pattern. In those situations, we'll have to apply a more complex style of regression. And in some cases, you might know what your data will look like. And so, like in this case, we see that our data follows a polynomial pattern, and maybe we don't know the order of the polynomial, but we know that in general, it's going to probably follow a polynomial, some sort of polynomial pattern of some order. Then we can fit model parameters to follow the general form equation of a polynomial equation. So, for example, if we have data that look like this, we might learn to fit an equation y equals ax to the bth power plus c, where again x is still the input, y is the output, and now the parameters are ax to the bth power. Or if you're trying to do a higher order polynomial, you might have ax to the bth power plus cx to the dth power plus ex to the fth power all the way ... to z plus a plus alpha plus some. We have to go into Greek letters eventually. And so then you apply the same process of gradient descent, which we will cover in an upcoming video. We're just building the intuition now in this series. So stay tuned for us to learn the math behind, given a general form equation with parameters like a, b, and c in this equation, or all the letters that we just talked about, or m and b and y equals mx plus b, whatever the equation is that's parameterized, learning the optimal parameters that best fit the data. So hopefully now the intuition for regression is clear, at least what our objective is in regression. We're going to cover classification, the intuition behind classification next, and then we will talk about the math. So stay tuned.